Good morning and welcome back to this seminar. Today we are going to talk about one of the most important and relevant risks in the operating room, namely glare. To talk about glare, I would like to start with a definition available from the literature. Some surgical lamps gave too much illuminance, which made it harder to see. Why do I like this definition? I like it because I think it is representative for talking about the problem. In order to understand it, I would like to divide the sentence into its three constituent elements. That is, the result, impairing vision. The reason, i.e., too much light. The literature has clearly identified how too much light is at the root of the glare problem. And finally, the subject of the sentence, namely some lamps. I like this definition because precisely it does not talk about all surgical lamps, but it discriminates between them and only considers some. And this means that not all surgical lamps impair vision, either because they do not produce too much light, or as we will see in the course of the video, for other reasons. Of the three elements that makes up the sentence, that of too much light is thus the one aspect most subject to interpretation. Let us therefore try to understand what is meant, or what the researcher meant by too much light. We can say that there is too much light when we are dazzled, and that is because our vision is impaired. This is quite uncontroversial. If we refer to a real-life experience, we see how natural it is that while we are out walking, we get to our sunglasses to protect our eyes. This is because the sunlight is very intense and it is bothersome. Even worse, if we spend a whole day in the snow without glasses, we return home from our outing tired, distracted, irritated, and probably also with slight watery eyes. In short, if we spend a day outdoors without any protection, we might be affected by it. We may experience the same problems highlighted by surgeons in the operating room, with the difference that they are not out looking for mushrooms, but precisely they are operating on people. So let us try to address the problem of glare by keeping true to this metaphor of nature. Two different and distinct classifications in the literature aid in our understanding and categorization of glare, allowing us to compartmentalize it. The classification and distinction of glare firstly depends on the specific situation, forming the first category of this phenomenon. There are in fact two instances of glare filtered by the situation in which they occur: luminance and contrast, respectively. On the other hand, one can also categorize glare depending on its type, allowing for differentiation based on this factor. This classification discriminates between direct and indirect glare. Let us therefore begin with the first instance of glare, namely that based on situation, that which discriminates between luminance and contrast, and let us try to understand what these two terms mean. Luminance is the presence of excessive values of light. That is a far too high ratio of light intensity to light emitting surface area. Let's go back to the outdoor walk and attempt to determine the nature of this particular situation. We will experience the effect of luminance when we look up and intercept the sun. Despite its true enormity, the size of the sun appears small enough that it could be easily concealed and covered by a single finger. However, what falsely appears as a small lighted surface produces such intensity as to be destabilizing. Indeed, by intercepting its light beams directly, we will experience firsthand what are referred to as black spots, and this will impair our vision. Furthermore, black spots remains on our vision for a long time, and this even worsen our frustration. By looking directly at the sun, we experience what surgeons daily experience in the operating room. After all, the surgical lamp, producing 16,000 lux, is a light source with a very high intensity, especially if we take into account that the average size of the surgical lamp reflector is about 60 centimeters. Therefore, we see how the luminance experienced in OT room, when compared to the situation of the sun, makes quite a fitting analogy. We have a very small surface area, in this case a relatively small one, for we are talking about 60 centimeters, and a very high luminous intensity. We are in fact talking about 16,000 lux. This situation is further exacerbated when we consider the context where the operating light is installed. And this leads us to define the second element of this distinction, namely that of contrast. Contrast, in fact, considers the difference between areas of different brightness. Essentially, taking a further step back and reverting to the example of nature, we can think of the situation of when we enter and leave a tunnel to understand what contrast glaring might cause. Whenever we drive into or out of a tunnel, we need a moment to readjust our vision as we reach the area with a different brightness. We need a moment to readjust to the new condition of brightness. Meanwhile, we remain dazzled. Here, this very same situation happens in the operating room. We were just saying that the surgical lamp generates a light beam of extreme intensity, but still we kept silent about the context, where this lamp is being used, which is that of the operating room. During operations, general lighting is usually kept off or very low dimmed. So the situation in which surgeons find themselves operating is that of a room, with a very high intensity light source over the operating focus and a dark surrounding area. If we consider that the surgeon operates on the surgical focus, that is, the area directly illuminated by the surgical lamp, and we realize that he is not operating in a vacuum. But precisely inside an operating room, we find how natural it is that in the course of the operation, the surgeon's gaze wanders within the room, thus moving back and forth from the dark area, and constantly returning to the highly lit surgical focus area. It is precisely in the difference between the brightness of these two areas that contrast glaring is experienced. Moving forward to the second classification of glaring involves a differentiation between direct glare and indirect glare. Let us first address what we mean by these two concepts. Direct glare occurs when the source of discomfort can be directly attributed to the light source. The experience is directly linked to the brightness of the light, in this case the surgical lamp. I look directly at the operating luminaire and I feel dazzled. Indirect glare, on the other hand, is experienced whenever the light generated by the surgical lamp is reflected through other bodies. In the operating room, these other bodies can be the surgical instruments, the monitors in the room, or the anatomical tissues. Now, we have made a very scholastic division of what may be the types or the situations when and where glare might occur, and we defined 4 groups of glare. However, behind these 4 groups, there is a generic premise, a unique premise, which is the presence of a huge quantity of light. In fact, too much illumination leads to black spot in the luminance case, to extreme fatigue, loss of sharpness, inability to recognize tissue, dryness and burning eyes in the case of continuous adaptation, namely the contrast. These situations are exactly what jeopardize safety in the operating room. It is crucial to address these issues to ensure patient well-being. Fortunately, there is a solution, and in fact it is possible to reduce glaring, thus making surgery safer. How? The only solution comes from the light source technology in use on the surgical luminaire. In particular, it has been proven how direct light lamps are particularly prone to cause glare, while lamps with reflected IE, displaying an indirect lighting system of reflection, greatly reduce the risk of glaring up to a point of almost eliminating it. Therefore, a meticulous choice of the reflection technology in use on the surgical luminaire is crucial with respect to the dazzling derived from the luminance. This choice plays a key role in glare abatement, so much so that it is possible to achieve almost complete elimination of glare using double reflection technology. With the use of double reflection technology, the amount of light to the eye is almost zero. Taking a view at the chart, we can see how the amount of light reaching the observer's eyes, namely the luminance, is significantly less at different angles, where the lamp displays an indirect lighting technology, other than a direct reflection solution. But just as there is a technological solution for luminance, contrast glare can also be avoided through the adoption of specific technologies, such as creating a compensation area between the surgical focus and the surrounding area. More specifically, this solution provides that, regardless of the choice of the surgical focus diameter size, around it there is an area with a constant intermediate value of illumination, such that the transition between the area that is highly illuminated and the poorly illuminated area is smoothened. Indeed, Studies have shown how this implementation has led to an 11% improvement in surgeons' visibility, with a 13% reduction in errors and mistakes due to wrong color recognition. Just as we have seen that technological choices allow to reduce the effects of direct glare, the strategic implementation of design and manufacturing techniques effectively mitigates risks associated with indirect glare. Now, when it comes to instrumentation, one can reduce indirect glare by selecting different materials or finishes. For instance, there are certain choices that can help in this regard. A certain controlled finish will reduce indirect glare, and similarly, it is possible to reduce up to the point of eliminating indirect glare derived from the light reflected on monitors through the application of protective screens. The only instance of indirect glaring that cannot be counteracted through technology is indirect glare caused by light reflected from anatomical tissues. In this case, it is very difficult to technologically intervene in order to avoid this glare. To this day, the optimization of light sources has been achieved through the incorporation of a reflected light or by including a compensation area. The principle remains unchanged. These tools have been proven as the most effective means to combat glare, which is widely recognized as the primary issue in the operating room. In conclusion, therefore, I would like to return to the initial definition. We saw at the beginning of the video how some surgical lamps produce too much light and this impairs vision. The researchers effectively define glare by encompassing all possible conditions with a broad and comprehensive approach. With eyesight is excessive brightness, as evidenced by the blinding output of surgical lamps that emit an exceptionally high level of light. Our analysis has provided insight into this matter. We have analyzed the ways in which this far too high light translates into a safety hazard. We then considered 4 types of glare: luminance, contrast, direct and indirect glare, and the effective utilization of technology can significantly diminish, if not altogether eradicate, this potential hazard. Through the use of indirect reflection and the presence of the compensation area, and the use of special finishes on surgical instrumentation. Therefore, we can understand what was meant and what the researcher meant by limiting the problem to a few surgical lamps and not stating that all the surgical luminaires produce too much light. We witnessed the negative impact of glare, which often leads to errors. We can even utilize the findings from various sources that emphasize this point. Glare is of utmost importance to address in the operating room, as it is the primary source of error. Hence, it is highly critical to create awareness about this issue. Experts in the field must have a complete understanding of this, as there are various technologies that are capable of reducing up to the point of eliminating this risk. In conclusion, I would go so far as to say that the important thing is not to compromise on quality. I thank you for viewing this video, and I recommend that you subscribe to the channel to stay constantly updated on new items. Have a great day.